the chapter Some Basic Concepts of Chemistry from NCERT Class 11, Part 1. I'll be reading from page number 1 to page number 10. You can just plug your earplugs, close the eyes and listen to it, as it might help also. So, page number 1. Science can be viewed as a continuing human effort to systematize knowledge for describing and understanding nature. You have learned in your previous classes that we come across diverse substances present in nature and changes in them in daily life. Curd formation from milk, formation of vinegar from sugarcane juice, on keeping for prolonged time and rusting of iron are some of the examples of changes which we come across many times. For the sake of convenience, science is subdivided into various disciplines: chemistry, physics, biology, geology, etc. The branch of science that studies the preparation, properties, structure, and reactions of material substances is called chemistry. Development of chemistry. Chemistry, as we understand, is not a very old discipline. Chemistry was not studied for its own sake, rather, it came up as a result of search for two interesting things. First, philosopher's stone, that is Paras, which could convert all baser metals, that is iron and copper, into gold. Second is elixir of life, which would grant immortality. People in ancient India already had the knowledge of many scientific phenomena much before the advent of modern science. They applied that knowledge in various walks of life. Chemistry helped and developed mainly in the form of alchemy and itrochemistry during 1300 to 1600 CE. Modern chemistry took shape in the 18th century Europe after a few centuries of alchemical traditions which were introduced in Europe by the Arabs. Page number 2. Other cultures, especially the Chinese and the Indian, had their own alchemical traditions. These included much knowledge of chemical processes and techniques. In ancient India, chemistry was called Rasayan Shastra, Ras Tantra, Ras Kriya or Ras Vidya. It included metallurgy, medicine, manufacture of cosmetics, glass, dyes, etc. Systematic excavations at Mohenjo-daro in Sindh and Harappa in Punjab prove that the story of development of chemistry in India is very old. Archaeological findings show that baked bricks were used in construction work. It shows the mass production of pottery, which can be regarded as the earliest chemical process in which materials were mixed, molded, and subjected to heat by using fire to achieve desirable qualities. Remains of glazed pottery have been found in Mohenjo-daro. Gypsum cement has been used in the construction work. It contains lime, sand, and traces of CaCO3. Harappans made faience, a sort of glass which was used in ornaments. They melted and forged a variety of objects from metals such as lead, silver, gold, and copper. They improved the hardness of copper for making artifacts by using tin and arsenic. A number of glass objects were found in Musky in South India from 1000 to 900 BCE and Hastinapur and Taxila in North India from 1000 to 200 BCE. Glass and glazes were colored by addition of coloring agents like metal oxides. Copper metallurgy in India dates back to the beginning of Chalcolithic cultures in the subcontinent. There are much archaeological evidences to support the view that technologies for extraction of copper and iron were developed indigenously. According to Rigveda, tanning of leather and dyeing of cotton were practiced during 1000 to 400 BCE. The golden gloss of the black polished ware of northern India could not be replicated and is still a chemical mystery. These wares indicate the mastery with which kiln temperatures would be controlled. Kautilya's Arthashastra describes the production of salt from sea. A vast number of statements and material described in the ancient Vedic literature can be shown to agree with modern scientific findings. Copper utensils, iron, gold, silver ornaments, and terracotta discs and painted grey pottery have been found in many archaeological sites in North India. Sushruta Samhita explains the importance of alkalis. The Charak Samhita mentions ancient Indians who knew how to prepare sulfuric acid, nitric acid, and oxides of copper, tin, and zinc, the sulfates of copper, zinc, and iron, and the carbonates of lead and iron. Rasopanishad describes the preparation of gunpowder mixture. Tamil texts also describe the preparation of fireworks using sulfur, charcoal, saltpeter, that is potassium nitrate, mercury camphor, and etc. Nagarjuna was a great Indian scientist. He was a reputed chemist, an alchemist, and a metallurgist. His work, Rasratnakar, deals with the formulation of mercury compounds. He has also discussed the methods of extraction of metals like gold, silver, tin, and copper. A book, Sarnavam, appeared during 800 CE. It discusses the uses of various furnaces, ovens, and crucibles for different purposes. It describes methods by which metals could be identified by flame color. Chakrapani discovered mercury sulfide. The credit for inventing soap also goes to him. He used mustard oil and some alkalis as ingredients for making soap. Indians began baking soaps in the 18th century CE. Oil of Iranda and seeds of mahua plant and calcium carbonate were used for making soap. The paintings found in the walls of Ajanta and Ellora, which look fresh even after ages, testify to high level of science achieved in ancient India. Varaha Miher's Brihat Samhita is a sort of encyclopedia which was composed in the 6th century CE. It informs about the preparation of glutinous material to be applied on walls and roofs of houses and temples. It was prepared entirely from extracts of various plants, fruits, seeds, and barks, which were concentrated by boiling and then treated with various resins. It will be interesting to test such materials scientifically and assess them for use.